If this works, see, I believe it's this one. No, it's that one. That one in the middle is the 0.6 apparently. So you're gonna go over here. This is the parents' place. So there's that, going on. I'm here doing laundry. This is their workshop. That's how that works. That tried to fall, right? Anyways, so I was thinking about this because I was like, fucking Christ, there's a whole bunch of shit right there. You don't know that. You can't see that. That's not a thing. It's not really there. We'll just tilt this. Why is this that off? What the fuck is this? Anyways. So fucking... Yeah, no, all of this is obviously gonna go into the video. Yeah, every bit of this and everything clearly needs to... I was going to talk about something that was important, and now this is far more important. Actually, I already had this going. So, like, there's that now going on, right? Standard stuff that, you normally probably wouldn't do. So, that's probably not the, we'll just fucking try to not have that be fucking off to the side. Anyways, there we are. So now this fucker is in there, just draining all of its water onto that. And I know this is going to sound a bit weird, but this is actually going to be important. This is called how to turn oxygen into a baryonic state and store it for, you guessed it, rocket engines. Because I like rocket engines. I'm a big rocket engine guy. And I'm like, how the fuck do I make oxygen? Turns out I can't just Google that. I'm like, all right, so how do people... And then it's like, oh, okay. So it's a lot of cooling, a lot of ordering it through a resonant state of a given type of like Bose-Einstein condensate kind of thing. But it's not really a Bose-Einstein. Okay, and then you have to compress it using fields, which not only order spin, but also order where, ultimately speaking, they view themselves as being. Which is a way of putting, that's not really what that is. But, like, effectively, kind of, somewhat. And it's like, yeah. So anyways, you already have to cool oxygen down, right? You're going to end up doing an electromagnetic frequency of multiple coils inside of the container. Which isn't really an electromagnetic frequency because, of course, you can't just shine light at something. You know what I mean? So it has to be a bunch of fields. Not just a regular bunch of fields. They have to pulse and resonate from one end to another. Then they have to also hold this in a suspension. They can't ever touch the sides of the vessel because, of course, they'll go through it. Because, of course, they shrink, right? So anyways, this is magnetohydrodynamics, but using the resonant frequency pump of both of those into its condensed state of matter that allows for it to then float and never actually touch the sides, right? Now, if you know anything about that, then it's like, congrats! You're further ahead than basically everyone about baryonic states of matter. You're going to want that because then you can already stop the video and just immediately proceed as forward and just do that. Otherwise, you're like the rest of us who are not your PhD motherfucking having asses on this shit. So deal with that. Why don't you shut up about how that's not a thing and that's not, and I looked up and the wikis. I'm like, okay, the wikis. Got the perfect fucking answer from Wikipedia, huh? It's perfect. There's literally not even a chance Wiki's ever been wrong. Never. But anyways, I'm going to move on to the basic simple stuff here. Baryonic is not necessarily what you think it is. Although, that's debatable in its own right, for what it's worth. Because there's a lot of people that debate about that in theoretical particle physics in terms of whether or not ultimately, just because we can't view it as a separate, they're so close together and they are mimicking each other so significantly closely that they've effectively turned into one state, right? Which is cool, but like, there's some wiggle room on that measurement and the uncertainty of it. because if you are uncertain about this, then that means the measurement of your thing, which is fermionic, by the way, isn't exactly very quantumly speaking certain. So it doesn't really work very well to be like, no, I know, I do know. How do you know that? I'd like you to say you're a little unsure, you little fuck up. God damn. Shit, right? Anyways, to me it's like, all right, well, we're not entangling anything. That's not what that really is. What we're trying to do is condense it, order it, and then force it to effectively mimic being one thing. But in order to do that, we have to take the elicited fields, meaning fields that are expelled as a subatomic to a full, elemental particle or atom in this instance, that are, outside, all the way to the electron orbits that, of course, have an even larger expanded field beyond where those given tiny, tiny subatomic particles are, right? So, when we are aligning them via electromagnetic frequencies and pulsing them and resonating where they're pulsing and allowing for them to shift backwards and forwards, we have the ability to remove a little bit as they move. That maintains, actively speaking, its cooling. Okay, but also it aligns both spin, which is like the whole quantum vacuum decay measurement, right? It's like, no, there's an electromagnetic field, and it's really more of in a superpositional state where it'll collapse into becoming this higher energy state. It didn't really go into a lower energy state, but whatever. I'm going to get off of that, because that's another debated, no, it does mean this, and I saw a video that means that. And I'm like, shut up! I don't care what you saw. There are many ways to interpret things. Can you shut up? You're one of those stands that's like, it's only this. They said it's only this. No, they didn't. They didn't say that. They said it is this thing, possibly. That's what that meant. You know what I mean? Which it's like, yes, but also here are other ways, which is what science really does, to interpret these results. You fucking stupid cunts. Shut up. Anyways. So, we're going to get into how we're not just aligning spins, we're not just aligning poles, we're not just aligning a lot of that by doing this. We're also condensing it, and we're able to force them, and then they'll stick together, and then compress, and then they'll stick together, and then compress, and then we'll stick them together, and then compress some more, and we'll stick them together. And resonate and cool them off and cool them off and cool them off and cool them off until, is there too much of a difference? You know what I mean? Which side? Truthfully speaking, that's kind of what that is. It kind of feels that way to me. But it's like we're basically forcing it to maintain itself inside of a vessel while doing that, which is wonderful. It'll passively start to do this to a point. Of course, we have to still ultimately provide energy, right? Because, shocker. Who would have thought? So, no perpetual, man. Sorry. But for me, it was like, I can shove a lot more oxidizer in my burn chamber. Let me just, as it goes from its given, I'm a small little tiny baryonic state. Look how small, I'm a small little guy. I'm just a small tiny little, bam, just expand, immediately take all of your energy. What are you? Something you can oxidize? What is that? Electromagnetic fields, bitch? Give it to me. Nom, 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 nom. As electrons all exchange, they do their little happy dance of, I'm now chaotic. Guys, chaotic. Fucking. But it's like, yeah, okay, sure. Meanwhile, how many times can I compress and condense that fuel if I cool it off like this? I just would like to know, not just hydrogen, which I could do that with hydrogen and like helium and stuff, but like honestly, how hard could I like do that with like certain compounds? Like honestly speaking, you know what I mean? Hydrocarbons are nice, but like what about like just straight like barely a liquid carbon? You know what I mean? Like is an oil just fucking chock full of carbon? Which I know that sounds stupid, but it's like, but I can then shove it into the blast chamber and really increase the amount of heat and outright chaotic. movement, right? You know, kinetic. It's just like, yeah, but if I do this, wait, hold on. If I do this, because you got to hold on. Got to do this the right way. It's like, well, why wouldn't I want it to burn a very specific way that allows for it to continuously travel and resonate off of its, tapering into the nozzle point, which of course is going to speed it up. But it's like, if I do that the right way, it'll reflect back and help increase pressures back towards where it's going to burn, which, by the way, you can't do sparks or something? What the fuck is this? How does that work? You can't like zap. I thought so many people have zaps these days. You're like, oh, I can use this to baryonic up a fucking oxygen chamber. I'm like, but you can't make a spark? How does that work? How does that work? That doesn't make any sense. Like you can't. It's still gonna be hypergolic because of like how fucking oxidized that would become, and like how much it would readily oxidize and try and burn, right? But it's like you start off as a much leaner mix, and then it'll rapidly heat up into that chamber, and then it'll go really hard, right? But it's like I can store way more fuel, and it's not like the mass went like nowhere. We know that the mass is still there, right? But it's like, I mean, it's going to turn into a solid. You know what I mean? But it's like, no, well, yes, kind of, yes. Except we can ablate away that solid because it's in a solidly fixed triple point, I suppose, or not triple point, but like a critical point. When it's so cold and we're resonating it like that, that means it's like stabilized into this like weird point of where it's technically both a liquid and a solid under the pressure and the condensing it's in, right? And so as a result, it's like, and I can get that. Like it's not going to turn into a gas, but briefly it's going to look like it's a gas, right? And it'll destabilize, and that's something I can immediately grab, and that's the resonance and the pumping kind of action, which then means I can shove it in to that chamber. But if I make it so that way, and this is a parabolic spike, if you will, I call it that. It's a Hershey's Kiss. That's a crown, effectively. It's a bunch of little waveguides that are there that'll go in. They fire inwards towards where the nozzle is, and then towards on the outside, towards the tips. As they burn towards the center, they'll go out, and then that reflectivity wave comes back towards on the parabolic spike that then gets this like little, what is it, the fucking, it's the Venturi with the other guy effect that then allows for it to come in, and that'll help with the outright burn speed velocities. Right, but that also means it then starts angling itself very, very quickly. You know, expansional energy, kinetic, will go outwards, but then a very hot, very much faster core starts to pick up speed. And so it creates a pressure on the outside that forces the center core to get faster, which is perfect. That's what you're going to want. That also means, the whole like, well, if I just shock the fucking hell out of this, just look at this tapering like little nozzle, just imagine some cup, just get a cup and then like cut some things into it and then slide it like another. Anyways, point is, it's a bunch of teardrop shapes that are stators that are stuck there, but it's like initially it doesn't look like they're there, right? But it's like, no. And I'm here all of a sudden. I'm now suddenly there in the path, and that compresses it even more. But if I put them close enough, with enough electricity, I get something where when I have an electromagnetic toroidal shape, kind of like these bad boys, a little fucking circle, I can squeeze the inside of that while I'm squeezing it and try and force it to align itself and orientate itself faster through the nozzle and come out even hotter on the other side, which is great. But I was like, wow, that sounds like a lot of heat. It sounds like a lot of concentration of heat. Well, no, that's because I have this electromagnetic field that I don't have to worry. You see, it passes by so briefly. It's always there. You're not wrong, though. It's going to melt. No, but I'm cooling it, you see, with my liquid cooling of the, baryonic oxygen or fucking whatever the hell I've got, you know what I mean? It's like, it's too cold, my fucking carbon impregnated oil shit. It's too cold. It needs to warm up a little. It's like, run extra lean in there because this is like, oh, remember that? Remember that bell end? Well, if I'm cooling it there, I can just shove in oxygen, or in this instance, just straight fuel, like right there at the end, as it like wants to spread out. And I need it to spread out more evenly throughout the entirety of that bell end and aerospike kind of combo that I usually use, which then allows for it, which is a weird way of putting, take a cup and then stick like a pointy spike in it. And then when that's there with stators that have to be there, then fuel go and fast, much faster. Anyways, then it decides to go the other direction of wherever that's going. So, that's good. But so you understand the basic principle. It'd be very high specific impulse and very large delta V, because I would be able to compress it and condense it into a smaller area, and I can have more on board of the same area. Of course, that means I do need to store electrical energy, which means, of course, not just the coils, I'd have to make sure that housing also happens to contain some amount of a pack of batteries that are either reusable, or I can make electricity from the pyro and piezoelectric activity possible in the blast chamber. Sorry, not blast chamber, although it kind of feels like one at that point. The burn chamber, So there's it's burning thing. We're not exploding. Detonation velocities achieved. Shut up over there, you. Anyways, but it is basically kind of like that. The amount of energy that we would be technically possible to store, able to be, used. But it is a technicality. I mean, we're talking about we have to maintain it under those G loads. We do have to do that kind of a thing, and we have to maintain a constant burn. So it's like, this is all testing stuff, right? But it's like, from what I understand, we can force a type of compression which is a quasi-baryonic state if oxygen can't turn into a baryonic state. But it would be a quasi-like baryonic state. We would have condensed and compressed a gas that otherwise would have been just a liquid. Of course, it's still going to be a liquid. It just starts acting more and more like kind of like a superfluid that can continuously kind of go closer and closer to itself, like a baryonic state, right? But of course, that's ordering and resonating it back and forward, and then compressing it, and then doing that over time, and then cooling it, and then doing it again. And so it takes a while to get it done. But of course, you have to have a changing size of vessel. So you'll start with a larger, and then that has to get dumped into a smaller, and that has to get dumped into a smaller, and that has to get... So that way, those electromagnetic fields, because of course, inverse square law, shocker, still exist. So you do have to get it smaller and closer to what everything is that's inside of it, which is great. Kind of. There is a kind of, because it's like, there's a caveat here. It's like, how large can we make that state continuously exist? You know what I mean? Like, can I get it as a thimble? Or can I get it as a huge ocean, which isn't really, but Olympic-sized swimming pool? Can I get an Olympic-sized swimming pool of baryonic state of oxygen? Stop making explosives, okay? Why do you want to kill everything? So I imagine someone over there that's trying to manage me in science shit. Stop making explosives, you dick. No, it won't. It'll readily oxidize and change. It's under a massively condensed and compressed state, so it's like it will rapidly expand and rapidly want to react with anything, even itself. It'll try and basically form its own type of weird structure depending on how it's interacting either with the compressed or, anyways, point is, but that'll decay very quickly, meaning it'll cleave and break off and, just become more atom, to go react to something. But moving on from that, then it turns into, well, still though, at least a very carbon onion ball, right? Yeah, right? Carbon onion balls will totally work as an impregnated oil structure, because when you cool it and you condense it, it get in there and kind of bend and wrap around, right, into like certain types of carbon onion balls, right, and or fullerene structures, or even just graphite or some graphene. So what it allows is it's just like polystructural, polymerized, polycrystalline kind of things to occur for this type of fuel. Of course, we are talking about keeping under immense pressure and very cold while making sure it's constantly moving and getting interacted with just the right way, so that way it stays in a much smaller kind of area. But of course, it's the ablation, as I like to call it, because it's more of a boil and a sublimation. But I call it ablation because it's going to be a solid thing that's just like, we'll take off this amount and let's just get that for a while. And it's like, that sounds like a solid rocket booster. And it's like, yes, thank you. Yes, it's a solid rocket booster. As I stand here like, yes, absolutely it is. Yes, that's right, it is. Yes, it's a different type. We just, pick and choose the amount we're using at any given time by using timing and frequencies and rotations. Oh wait, we're not using rotations actually at all. Except, are those called spins? Well, they're certainly in there of the electromagnetic and resonant frequency. Because of course, you have to pulse them and you have to have others around, and then as it goes forward, it gets repulsed, that field, as it tries to decay against another field, so it'll go inwards, and then you have to head that closer towards the center of the given vessel, but also manage to make sure it spins the right way while doing that to effectively reorientate itself as a horizontal and a collapsing downward kind of Z-pinch-ish current, which is a Lemke force versus a Lorentz force, although I'd be using a type of Lorentz force to make that occur as it heads in, because as a decaying opposite electromagnetic vortex field that collapses, which then creates another one towards the center that then heads and then curves off and then resonates, right? Except depending on how you do that, you can get it to go back up or decay just directly in towards the center, which is why it's called a Lemke force versus a Lorentz force. That's right. I coined it because I made the idea and concept. I can't find it anywhere online. So suck it. It's a part of my Lemke phasing principle. You gotta get a whole bunch of fucking coils. You gotta get smaller coils and medium coils and different directional coils. And you gotta get bigger coil, and then you have to have line coils. It's a whole bunch of fucking coils. But when you do it the right way, then it goes, and then things go whatever direction that you want, because you force charges and electromagnetic properties to remain while also orientating everything and then having it tunnel around. So it tunnels as it collapses, then creates another one and opposing. So it'll go, and then it comes out the other way, that kind of thing. Anyways. But if you make sure that it's pulsed and it has the right timing, then of course you get different directions and different compression and different cooling aspects and ordering aspects and stuff like that. It works off the fundamental principles of how information travels through any given quantum system, which is why it's called a Lemke law in my math and physics that I use. So that's what that is. I don't write them down, they're in my head, so you're going to have to deal with that. But I've talked about them many times on my YouTube channel, so there's that. But, whatever. Writing things down is hard. I rarely do it. So, moving on to, well, that's great, but that also means it's like, well, that's a very highly explosive. Well, not the fuel, which is good, but oxygen is, generally speaking, quite explosive just in its own fucking right. There's nothing I can really do about that. It won't pass because of the electromagnetic fields that you have to maintain through the vessel, which is the good part. That's the only really good part, you know what I mean? It's just like, no, baryonic likes to just go through everything. It's like, yes, I don't disagree in the slightest. It will definitely try to do that. But also at the same time, fields. Have you heard of them? They're the things that make it so we have a membrane between us and potential land and below the quantum foam, and why we even have a quantum foam to begin with. And that's where the membrane exists, as a field kind of area that's an infinite, technicality-wise, But, you know, fields aren't really technically infinite, but then, like, we treat them like they're infinite in math. It's a whole thing. So there's that on that side. Much like the 1 is definitely bigger than a 0.9 repeated, because it just finitely sticks to 0.9 as one whole thing and can never get an extra to get it to become a 1, because that has to come from somewhere. So there's that. But for me, it turns into, remember that electromagnetic, like, toroidal thing? If I can fucking shock it just the right way, it's like I can turn this into a really fast-moving, resonatively speaking, also collapsing plasmification sort of system, which means I can try and force this to try and compress itself even harder. And if I can just barely, like, get a little bit in that nozzle, I can get it to go wrap around towards the other end of where the stators are on the other blade, instead of the little crown where it's going to burn and kind of like mix like that. And then we'll fire into that. And then that allows for another reheating effectively, right? And then that allows for seeding for plasma while creating a, because that's going to be, if I can make it a lower charge or something like that, it can become an attractive effect for charge, right? But then I can also compress it and re-accelerate it. And that allows for an electromagnetic for the both the reflected pressure wave and movement of that gas, along with the gas from the plasma, which then will slowly create a faster and faster Z-pinch and a electromagnetic and electrostatic, in this instance, charge effect and repulse and attractive force effect, which is great because it means I can accelerate it. I can use less mass, less burn, I get greater velocity, and that means higher specific impulse, right? Which is kind of like, yeah, no, I want to get rid of certain people, you know, rage bait, they probably aren't listening, and then it's like, oh, hi, so this, what if I did this? What if I did that? Now, it's carbon, so it's not really likely to get me any fusion or anything, but I could theoretically get so close. You know, it's tasty. It's right there. It's like I can smell it on my tongue levels of close, you know? If I could just inject some hydrogen, some deuterium or hydrogen, it's hot enough and pressurized enough and going and expanding fast enough that it could theoretically inject it and allow for deuterium and tritium burn into a fusion plasma area, but it's very low amounts of fusion, but it'll be constant ignition fusion. It'll be always on. That goes into the stream that's going out, which gives me a helium, but also gives me a boost of the neutrons, which increases, if I have the right area and stuff that's there, a reflectivity index that allows for me to increase neutrons in that area, kind of like fissile stuff, that could very well increase the overall amount of fusion I can get for each amount of the hydrogen, which, by the way, if I'm running lean anyways, if it doesn't fuse, it's okay. I have oxygen present and I get H2O, which is fine. I'll still be able to use that. You know what I mean? And so it's like, right, so I might get a little fusion, but if I don't, I still got H2O, and that's still more mass, and that's good. I'll take that. You know? Anyways, but then that goes out. That's why I have the aerospike bell end. So it's like once it goes there, it has to spread out and properly like take all of that almost like an atmospheric where it's in its chamber in space. So it's like in space because there's no atmosphere, of course. Kind of sucks. Bell ends are better than aerospikes once you get out of our atmosphere, right? But it's like it's forcing the aerospike to travel along the bell end to travel there, and then that allows for us to burn a little bit of extra fuel, right? But then it also means it'll burn inwards, as that's a pressure wave, right? So that creates its own, I'll squeeze inwards, that goes that other direction, but then of course that creates its own type of kind of like reflectivity index of an atmosphere that bounces off of the bell end and aerospike, which is great. You know, so it becomes more efficient, which is super awesome. Also, it means I can get plasma in space, right? While also burning possibly in a negative and or positive charge fuel to the plasma that's there, that's either positive or negative. So it gives me that charge attraction, which then gives me the extra kick from that electricity. So a higher Q value has now occurred, since I was going to have that electricity there anyways. And then I was like, well, if I'm going to have a piezoelectric, might as well, just a redundancy kind of thing. I have a generator now, effectively, right? So it's like, that would be way nicer than trying to believe that all those batteries will always survive, and everything like that. So then I'm like, yeah, then I can use that to burn way more quickly if I wanted to. But for me, it's more about outright energy efficiency. So really high speeds, much less mass, but it acts like it's more mass, which means I get longer specific impulse in delta V. It's a very high specific impulse, right? But I can also burn for longer, which then gives me a very high delta V, which is perfect. That's what the whole point was, but it's like, baryonic oxygen? I can't just search this up. They don't just have it, on the fucking, shelves. What is this bullshit? They just have baryonic oxygen over here. Why are my needs not catered to? I thought capitalism was meant for something. Can't just buy baryonic oxygen. Meanwhile, also on the other side, I can't just buy a fucking oil, maybe kerosene or something, and carbon onion ball, graphite, graphene, impregnated fucking kerosene that's been turned into a near baryonic state. What is the world coming to, honestly, right? I don't know. I don't think that's ever been asked for. You don't. That's because you didn't have it as an option. That I would have absolutely bought that. You don't understand. I would have bought that. I would have absolutely bought that. Oh, gosh. Anyways, a lot of the rest of my designs for any rocket engines are also scoop air. Air to cool air around, heat up air, inject air into stream. Stream then become lots air move because of was it the Bernoulli principle, effectively, right? So it's I also have a lot of electromagnetic, and it's quite hot, so it's probably a little ionized. That'll work. Whoosh. What do you know? I've got hot, ionized ass air that I'm going to attract to my negatively fucking charged plasma or something. I don't know. But I need to cool that fucker because it's hot. It's going to be so hot. Because it's the hottest that you can probably make a reactant because it's effectively mostly carbon with a little bit of hydrogen. And so it's no, I'll immediately just turn it into a large amount of electricity. And it's yeah, well, it's to cool off of something. Oh, look at this air. Lucky me. And that's some nice electricity you got over there. Well, it was a shame if I just used it to go even faster. Oh, it's not a shame. Anyways, look at my big schlong. I'm always using, though, instead of that, I use big vacuum airships. They have a vacuum inside, and then they're able to be rigid hold, but they can also expand and contract based upon sliding poles stuff. That kind of thing. Hourglasses that fit inside of themselves. So they're able to go and then, get stuck like that, but then they can, right? So it looks like they're smaller and they're a little bit stronger because you have a solid rod that's kind of threaded inside that allows for you to do that. Anyways, that allows for all of that to expand and then become much bigger. And that's great when you're at a higher altitude, but at a lower altitude, you don't need it as much, but it also means, oh, that's where I can store all my fucking highly explosive reactant. Oh my god, what? Buoyancy! Versus, I start on the ground. Don't melt over there, because it's going to come out real hot. It's going to come out real fast. We got it! Lots of water, just dousing water everywhere, just lots of water. Meanwhile, me... I'm just gonna use the fucking earth, it's wind. Just gonna fucking use some basic bitch engines, not even my rocket engines. Just kind of fly a little, drop them off. I don't need these engines anymore. These are your engines now, guys. Massively fast speed. You're above the slipstream. It's okay. It's not that big of a deal. What's the problem? You have a lot of oxygen, ozone. Don't burn our ozone! No, you don't understand. I trapped a lot of nitrogen and then I explosively decompressed nitrogen and oxygen together into the stream as and then compressed it. So that way I never burnt the oxygen. And it came out as ozone still, which is good, but I also had to use like the little ozone trickerino of like a fuel cell where it has to perform work energy, you know what I mean? Like the electron redox flow. Anyways, point just comes out as ozone and a bunch of N2s and O2s, which is great because that means burning anything extra over there would be nice, you know? Boof. Meanwhile, still getting up there. I'm orbiting. Look at me orbit. I'm going into the big vacuum area that I had in my ship. That's right, that's another area for me to just go into. I'm just going to go into my vacuum area. You know, as you do, standard stuff. You know, it just goes from this like little thing that's like kind of attached at the bottom and then it goes in and then, hey, what do you know? Well, I've got a lot more space. Thanks, man. Yeah, I worked hard to get that space for you. Meanwhile, I'm over here in the ISS. Yeah, I'm bigger than you. What? From one launch. I'm just gonna get my vacuum airship to get me more fuel. I'm gonna go over to the fucking moon with some extra fucking food and shit. Don't do this! No! Yeah, going to the moon, suck it. Fuck you! Don't care. I'm gonna do it. I'm gonna do it. You can't stop me. Where are laws? Where are your laws to my fucking faster than your stupid nukes? Ha! Fuck you, anti-laser bullshit. Shields. Yeah! So I go over to the moon. Having a blast with it, you know. Also, it's 1G acceleration. It's almost like I'm on the Earth. Look at me. I can just jump a little bit. Ow, that kind of hurt. I'm not where I used to be when I was younger. I'll tell you that much. Even a small hop gets me sometimes. Anyways. But there you go. But you have to also have baryonic states of matter and stuff. And it's like, no, but I mean, you could do it. What's the problem? I don't see what the problem would be, truthfully. You know, but it's like, it takes a little bit of effort, right? So it takes a little bit of effort to learn. So it takes a little bit of doing. You have to research and develop it, which is fine. But it's like, at least the initial prototype is doable right off the bat with regular shit that we already have. Why not? Right? Boom! Just go. Right? But it's like, how much extra would that give you? And it all depends on the amount of condensing and baryonicing, I suppose, of that given oxygen and fuel. So, you know, it's one of those things where it's like, no. They say it can't be, it'll just keep going into itself. So it means, like, theoretically speaking, you could, if it could turn into a real baryonic state, instead of a superfluidic baryonic-esque, quasi state, then it's like, then the answer is, unfortunately, we hope to get it back. The oxygen and fuel back. You know what I mean? Otherwise, it's like, what did it go into? It comes back every time. We get the same amount back. Right. But did we test that with an Olympic-sized swimming pool? No. Well, we just assumed then, right? What's the probability of it turning into something else? I don't know. Oh. Well, that sucks. So, anyways, let's not think about that too hard. Instead, let's think about burning lots of fuel as we continue to research and develop this very fucking really cool, but theoretically, what I was trying to drive at here, theoretically, that is a baryonic state means you could put an Olympic-sized swimming pool into a singular solitary atom size. So, there's that, right? And it's like, is that gonna go past the limit where we'll die as a fucking, black hole Schwarzschild guy? I don't think so. No one has any knowledge on that. What am I supposed to do then? How can I tell them about something I don't know? If you don't know, then I can't know. It shouldn't, though. It shouldn't, technically. I mean, it is an atom, though, so, I don't know. It'd be quite heavy. well, it's only the same mass. Are we like making it more massy mass? But then that goes into like harmonics and resonant amplification frequencies of wave functions, right? Because it's like, well, it's the same thing, but it's like only in one spot. So like amplifies its given type of wave function effect over time with a resonant harmonic with itself, right? But like, that's quantum fields versus quantum fluid, or quantum waves versus quantum field and quantum fluid, which it's like, they're all the same. Why do you do this? Why? I don't like you. I don't. You don't understand. I don't sometimes. It's like, it's all just frequencies that you're talking about. And then like they have different varying degrees of like overall, I guess like a luminosity. It's not luminosity, but it's like amplitude, meaning thickness, meaning like more, power with inside of that frequency. Instead of it's a faster frequency, it's just more power into that frequency. You know what I mean? That's why I talk about it like a luminosity. It's like, or like amperage versus, volts. It's like, well, there's a bunch of these, and it's like you can't go faster. The electron can't really go that much faster. So it's like, right, but it doesn't actually have more electrons, except it does. See, that's the thing. It does actually have, it has to have more electrons, but like, that's the thing. It doesn't, kind of, you know what I mean? It's a weird one where it's like, there are more electrons hitting because of the frequency being higher. So it's like, it's shooting faster. Like if you were to think about it, it'd be like a single pistol to then it turned into a Gatling gun, which is a higher voltage, right? Versus amperage, which is like, well, I got like 1,000,000 pistols and I fired them all at once. You know what I mean? And it was like, boom. And then whatever that was got hurt probably pretty hard. You know what I mean? Versus like, then we get into current, which is like types of Gatling guns and pistols combined together and pulsed the right way, which is pretty weird to think about, but basically, yeah, right? And it's like kind of the same thing with wave functions in quantized momenta. You know what I mean? For like wave functions and transfer of any given energy, which is information, by the way, over any given distance in any given amount of space in its many different dimensions, right? So then it's like, well, that's just a wave frequency with a given type of amplitudal and outright power volt and amperage, and it's a type of current pulse system that only interacts with the right kinds of pulse and current systems. That has a different type of circuit that's effectively attached to any given type of particle and any given type of atom, that kind of thing. But it's like, no, it works with this analog circuit. And I'm like, yes, well, if I pulse it like this with these other analog circuits, then it'll work with that. Otherwise, it goes, I don't see you. And I'm like, yeah, okay, yeah, well, to figure out the stupid cracking of this stupid code with the pulse and frequency crap. Give me your secrets. I must do this. But they're like, no, quantum fields, no thermodynamics, gravity's out. It's still fucking moving information, which creates a given type of slowing down as it attracts towards and or repulses towards as it transfers given informations. That means in a dimensional aspect, it produces a given friction and weightedness as things have to effectively move and do things relative to any of itself and the neighbors around it. That makes quantum gravity, but it's like, no, it's decoherence. And it's like, no, you see decoherence incorrectly. That's the definition of what ridiculous friction is. It looks like a large amount of turbulent forces in a fluid dynamic and thermodynamic manner, which then means, of course, it has to slow down and it has energy that expands and converts and does other things to other things, which is information moving, which then turns it into, instead of decoherence, we got gravity. And then gravity gets closer and closer towards looking like simple charge in a guess of a manner. It's not really charge, it's more of informational movement of the given fields and property of waves in a thermodynamic manner that is intrapedic. But people get all angry about that when I talk about it, which is annoying. So it's like, but it's just wave functions moving. Yeah. I hate you a little, just a smidge. It's like it is, but that's also why it's quantum fluid and quantum thermodynamics combined, you know what I mean? And with the field theories, because you have to have pressure waves as fields, which are not quasi and they can't be virtual. And that's why you also have vacuum energies, which are different, and they have an expansional force versus a compression force, meaning towards, because that's energy that's stored within inside of informational movement. As informational movement can now move faster, it then contains a given increase of force for that given pressure and informational transfer, which of course allows for expansion, because it doesn't have to do as much work and it doesn't bleed off as much. Right, but there's other things to that, because then it's like, oh, right, well, that means I didn't traverse as far. Because I didn't traverse as far, that means I'm able to effectively gain during a kind of collapse of the vacuum energy, because, of course, it has to move, and so it goes around the vacuum and technically through as its own given type of pressure field system. As a field isn't a particle. We're talking about particles here versus a field, and fields in their own right can also have lower density amounts of fields, which can then also allow for a collapsing as it's traveling and it's all orientated towards itself, and it creates kind of the same version of a Z-pinch, if you will, as it attracts towards things, and that's a baryonic, which then, of course, depending on how that works, creates a Lemke law of force, which then adds to it, and it gains more as a result of like Bernoulli's and a Venturi's type vortex and a Lorentz maneuver, effectively, that increases all of that and has it all try and equalize to a given wave function and pressure system, right? So anyways, it's a certain type of pressure, but it's like, yes, but you're very weak pressure, and I can overwhelm that pressure and make you turn into my pressure. Instead of, oh, you're trying to slow down, it's like, well, there's already this thing. Become my type of pressure, as I have a pressure wave ahead and a field pressure wave ahead that also happens to elicit little sparks, otherwise known as virtual and quasi-ghostly particles, right, that briefly exist in quantum foam. And then, of course, like that allows for a different type of transfer, because that's entropytic. It's always trying to become more ordered and more quick. Simple fundamental force stuff, right? So anyways, it then happens to increase the amount, but it has to sacrifice a little bit to do that. So it slows down initially, and then a vacuum collapses just a bit, and then, of course, that gives more energy during that. I'm getting energy, not from nothing, but from the fact that there's potential energy around in a multiple amount of dimensions, right? So as it transfers forward, it then gives you the result of increase, otherwise known as expansional energy, because it, of course, wants to become more ordered and more kinetically speaking, able to travel faster. Simple entropy. You know, but that also means it's like, well, gravity, and it's like, well, yeah, no, it becomes very cold after a point, right? It starts off very hot, and so it's chaotic. But of course, everything's clumped around this. So that's more ordered, right? It's not spread out and all this. It clumps. That's more ordered. So it's like the same kind of thing. It's more and more entropytic ordering, as it'll get colder and colder and colder, and more crystalline, and less movement, and less able to tunnel, and it'll collapse a little bit. But eventually, of course, it starts to interact with, well, I'm a big field of gravity information. So it's like it starts to interact with our membrane in quantum foam area. So it'll tunnel a little bit. It just takes a while. So, anyways, moving on. Behold, why fuels could be done this way. With frequencies and vibrations, man. You know, just gotta get that the hippie, you know, get out the fucking rave and all that, because I'm totally into it too. Like, give me my fractal fucking tie-dye. Just follow that frequency, bro. It's gonna get there, man. Look at my fucking massive, huge amount of fucking stupid particles after a while. It's just like, it bothers me. It's like there's so many on that table that we don't see. They're flashes in a pan, so brief. Why do you think I just go, it's not any of, I don't care what the particles are called. They're all tons. After a point, you're just describing a given type of effect, which is a circuit, which then just turns it into, it has this programming of this algorithm that does this to that, to if then this, then that, and a multitude of dimensions, which then means it'll move forward like that. Simple as that. I don't care what they're called. It just means this does this. These things interact this way. That's all it means. But they're like, no, you must learn the Ton language. I don't care about your Tons. I don't want to learn the Tons. I don't like the Tons. The Tons bother me. The Tons are stupid after a while. Anyways. All right. That'll be it. See ya. Bye.